A giant tower crane rises hundreds of feet into the air, but no crane ever lifted it. Steel structures appear on remote mountain peaks where no roads exist. Entire power lines are built across protected forests without cutting down a single tree. At first glance, it looks impossible. Then you realize something unbelievable is doing all the heavy lifting: a drone. Not a military drone, not a toy, but a flying machine powerful enough to replace helicopters, move construction equipment through the sky, and rewrite the rules of modern engineering. By the end of this video, you'll see why China's latest drones aren't just changing construction, they may be changing the future of infrastructure forever. Machines built to replace a crane. A drone has just lifted an entire tower crane into the sky. At least, that's what millions of people have been led to believe by the video. But the truth is completely different. And what's actually happening is even more impressive. Not inside a laboratory, not through CGI, but on real construction sites across China. A fully assembled tower crane weighs tens of thousands of kilograms. Once you factor in the mast, the counterweights, the base, and the entire structural framework. No drone on Earth today can lift a machine that massive, not even remotely. So what are you really looking at? Not one giant drone carrying one giant crane, but dozens of industrial drones quietly taking over the very job that tower cranes once performed. One steel beam, one load of materials, one flight after another, hour after hour, until the tower crane never has to arrive at the construction site in the first place. That's the real breakthrough. Not lifting power, but precision. 3 machines are leading this transformation. The first is the DJI FlyCart 100, starting at around $12,500, roughly the price of a used pickup truck, while carrying up to 100 kilograms in a single flight. Next is the Skytech S400, a heavy-lift drone designed specifically for China's national power grid. Priced at around $295,000, it can transport up to 200 kilograms per flight. Every part of its design serves one purpose: delivering steel, concrete, and heavy equipment into mountains where trucks simply can't go. But the real secret lies in one detail that most people completely overlook. Not the motors, not the propellers, but the winch system. Almost any delivery drone can fly from one location to another and drop off a package. A construction site is nothing like that. Imagine lowering a steel beam onto the edge of a cliff, placing equipment beside a live high-voltage transmission tower, all while powerful winds keep pushing the aircraft off position. The winch keeps the entire load perfectly stable, lowering it inch by inch, holding it perfectly balanced, placing it exactly where the crew needs it, without swinging into a worker, without hitting a power line, without crashing into a rock face. The moment it gains that capability, the drone stops being just a delivery vehicle. It becomes the lifting arm of the entire construction site. And when dozens of them work together, a mountain that once took weeks to reach becomes nothing more than another destination programmed into a flight plan. And that's perhaps the biggest lesson hidden inside this story. In construction, the greatest cost has never been building the structure itself. It's finding a way to get people and materials to where that structure needs to be built. If drones can eliminate the need for roads, cable systems, and expensive helicopter flights that exist solely to reach the job site, then are they rewriting the very first rule of construction? That's exactly what happened next in southern China. And the numbers behind that project surprised even veteran engineers. Maybe that's the biggest question this story leaves behind. Are we simply witnessing another technological breakthrough? Or are we watching the moment the rules of construction begin to change forever? Share your thoughts in the comments below. The mountain built from the sky. Somewhere in southern China, there was a mountain that, under traditional construction methods, would have taken months just to reach. Yet the entire power line installation was completed in just 3 days. No roads were built, no temporary cable system was installed, and not a single tree was cut down. The site lay deep inside a county in Yunnan Province, surrounded by towering limestone peaks and protected rainforest. It also happened to be part of a natural migration corridor for Asian elephants. Building a road would have meant cutting straight through one of the region's most fragile ecosystems. That left engineers with only the 2 traditional options: cut a road through the forest, or spend weeks installing a temporary cable system. Neither was practical. Here, the mountain always won first, and the construction schedule always came second. But this time, everything changed. A fleet of 16 Skytech S400 heavy-lift drones, developed for China's national power grid, and priced at roughly $295,000 each, flew pre-programmed routes into the mountains. Trip after trip, for 3 straight days, each drone followed its GPS flight path, hovered directly above the tower site, then carefully lowered steel components, concrete, and assembly equipment to the crews below using its winch, one piece at a time. The moment one drone released its load, it headed back down the mountain for another, while the next drone was already on its way. Together, they formed an aerial supply chain that operated almost around the clock. No single flight carried more than 200 kilograms, but hundreds of flights quickly added up. By the end of the project, 180 tons of material had been delivered entirely by air. That's roughly the weight of 30 fully loaded delivery trucks, lifted onto a mountainside, without a single truck ever turning a wheel. No roads were built, no forest was cleared, no cable system was installed. The mountain wasn't conquered from the ground. It was built from the sky, and that's what makes this story so remarkable. This wasn't a technology showcase. It was simply a power company solving a problem that conventional construction could barely handle. That's also the moment a technology truly changes an industry. Not when it amazes people, but when it quietly becomes the new normal. Yet moving materials was only the beginning. The next challenge was far greater: getting people away from dangerous cliff edges, out of raging rivers, and off power lines coated in ice. And in 3 different provinces across China, that became the bring-ins. Next mission these drones were sent to accomplish. When drones start taking people out of harm's way, moving materials is one challenge. Keeping people out of danger is another entirely. Under the old method, the most dangerous part of the job came before the repair even began. Workers had to carry every tool, every cable, every piece of equipment across a fast-moving river, then climb a mountainside covered with loose rocks. One misplaced step, one falling stone, and a routine repair could instantly turn into an accident. But this time, the one crossing the river wasn't a person. It was a DJI FlyCart 100, the same winch-equipped drone already transforming construction sites across China on its first flight. The drone carefully lowered repair cables and a complete toolkit directly beside the transmission tower, inch by inch, with such precision that the suspended load barely moved. No swinging into workers, no striking the steel structure. On its second flight, replacement parts and the remaining equipment were delivered to the exact location marked by the repair crew. Just 2 flights, less than 30 minutes. But the number that truly matters isn't 30, it's 0. 0 workers crossing that river. 0 boots stepping onto unstable rock. Sometimes, the greatest value of technology isn't measured by the time it saves. It's measured by the risks people no longer have to take. Then came Hubei. In the middle of a brutal winter, layers of ice had built up along high-voltage transmission lines, heavy enough to snap cables that were never designed to carry that extra weight, heavy enough to bring down an entire section of the power grid if left untreated. For decades, there was only one solution. A lineman had to climb a frozen steel tower, stand only feet away from live high-voltage wires, while working in freezing winds. For years, it was considered one of the most dangerous jobs in the entire power industry. But this time, 2 drones handled the entire operation. The first carried a controlled heat unit directly to the ice, melting it from the air before it could grow thicker. The second followed behind with an impact bar suspended beneath its frame, knocking away the heaviest sheets of ice before their weight could threaten the transmission lines. No one had to climb the tower. No one had to touch a live wire in sub-zero winds. And that's the pattern hidden behind every story you've heard so far. These drones didn't replace the crews. They replaced the most dangerous moment of every job: the river crossing, the climb, the moment a human life came closest to disaster. And if drones can keep people away from raging rivers, towering cliffs, and frozen power lines, what happens when the country building them begins asking an even bigger question? What else could this same level of precision accomplish? That's exactly where this story goes next. What do you think? Is this the most meaningful use of drones you've ever seen? Or does a future like this leave you feeling just a little uneasy? Let us know your thoughts in the comments below. America had this first and lost it. China wasn't the first country to develop this technology. America was. It got there first, then quietly let the opportunity slip away. The aircraft was called the K-MAX. At first glance, it looked unlike any conventional helicopter. Its twin intermeshing rotors crossed each other like an X. a design created for one purpose: to lift massive payloads with extraordinary stability. Later, Lockheed Martin and the U.S. Marine Corps transformed it into an unmanned aircraft. In 2011, 2 K-MAX helicopters were deployed to Afghanistan. Their mission was simple: deliver ammunition, food, fuel to remote outposts hidden deep in the mountains where every supply convoy on the road had become an easy target. And it worked. Over nearly 2 years of deployment, the unmanned K-MAX completed more than 1,000 missions, transporting over 3 million pounds of supplies. Without a pilot on board, without a convoy traveling dangerous roads. During one emergency mission in Yunnan Province, it delivered mortar ammunition to a military base under attack. Flying a route commanders had already deemed too dangerous for a manned helicopter crew. What made the achievement even more remarkable was the cost. Each K-MAX cost roughly $7.5 million to build, and only about $1,100 per flight hour to operate. By comparison, the CH-53E helicopter it often replaced cost around $41 million to purchase, and more than $22,000 for every hour it flew. It wasn't just safer, it was dramatically more affordable. It looked like the beginning of a revolution, but then it quietly faded away. Production never expanded. The technology never found its place in civilian construction or utility work. Then, in 2023, Cayman officially ended K-MAX production. After nearly 3 decades, only about 60 aircraft had ever been built. The technology had already proven itself on the battlefield, but it never got the chance to prove itself in everyday life. China chose a completely different path. Instead of building one extraordinary aircraft for extraordinary missions, it deployed drones like the Skytech S400 and DJI FlyCart 100 across hundreds of ordinary power grid and construction projects. Day after day, project after project, until seeing drones at work no longer felt extraordinary. One country built the machine, the other built an entire industry around it. And that difference was never just about technology, it was about the ecosystem surrounding it. In the United States, a heavy-lift drone flying beyond the operator's visual line of sight still requires case-by-case approval. In China, drone corridors are planned much like highways, permits, flight routes, urban planning. Everything is designed from the beginning to let the technology operate at scale. Perhaps the hardest thing to build was never the aircraft itself. It was the system that allowed the aircraft to become part of everyday life. And that difference leads to an even bigger question. Because if a machine is precise enough to place steel onto the top of a mountain, then perhaps construction is only the beginning. The real revolution was never the machines. Throughout the entire history of construction, one rule never changed. Before you could build anything, you had to build the road that led there. Today, heavy-lift drones are quietly rewriting that rule. Of course, they're not without limits. A heavy-lift drone like the Skytech S400 can't stay in the air for hours. Most missions last only a matter of minutes. That's why these projects rely on dozens, sometimes hundreds of short flights working together instead of a single long journey. Wind is another challenge. A powerful gust can turn a perfectly planned delivery into a serious safety risk. That's why every mission is carefully scheduled around favorable weather windows, not simply flown whenever conditions allow. Altitude creates another limitation. The thinner the air, the less weight a drone can safely carry. A drone capable of lifting 200 kilograms at sea level can carry significantly less at an altitude of 4,000 meters. This isn't science fiction. It's a real tool with real limitations, solving real-world problems. But beneath the story of construction, there's a much bigger story unfolding. The precision that allows a drone to place a steel beam on the edge of a cliff, follow GPS-guided flight paths, hover steadily in extreme terrain, and lower cargo with pinpoint accuracy. Doesn't disappear just because the cargo changes. If a drone can deliver construction materials to a remote mountain, then in principle, it can deliver almost anything else to that same location. And that's exactly why governments across the United States and Europe have tightened restrictions on Chinese-built drone platforms. Their concern isn't construction itself, it's everything else that the same capability could make possible. But restricting technology creates another challenge. Banning the most capable and affordable solution doesn't mean a replacement is ready to take its place. Even today, the gap between restricted and replaced remains surprisingly wide. And, perhaps, that's one of the most difficult questions in this entire story. If there's one lesson worth remembering, it's that the revolution was never about one extraordinary machine. It was built on hundreds of ordinary flights, repeated again and again, day after day, until terrain once considered impossible simply stopped being an obstacle. A drone placing a steel beam onto a cliff, a drone crossing a river in less than 30 minutes, a drone clearing ice before a lineman ever has to climb. Those quiet moments are what truly transformed an entire industry. One flight, one mission, one breakthrough at a time. And that brings us to one final question. If the sky is gradually replacing the road, where do you think will be the next place on Earth that suddenly becomes reachable? Share your thoughts in the comments below. Everything you just watched adds up to 3 lessons that go far beyond the drones themselves. First, the biggest expense in construction was never the structure. It was always reaching the place where the structure needed to be built. Remove that barrier, and the impossible becomes routine. Second, technology doesn't have to replace a worker to save one. It only has to take over the single most dangerous minute of the job, the river crossing, the climb, the moment closest to disaster. Third, and most decisive of all, the machine was never the hard part. The real advantage belongs to whichever country builds the entire system around it, the permits, the corridors, the market, not just the hardware. It doesn't need a faster drone to win this race. It doesn't need a bigger battery or a stronger motor. It needs permission granted in weeks instead of years. It needs a sky that was already zoned before the first flight ever took off. Thank you for staying with us through the whole story. If this changed how you think about what's actually hard about building something, hit subscribe. There's more of this coming.